Okay, in today's video we're going to discuss rational and irrational numbers. And the first thing we're going to do here is identify rational numbers. And basically a rational number is any number that can be written in fraction form, such as 1/2, 2/3, 5, and so on. So basically rational numbers are whole numbers such as 6, because 6 can be written as 6/1, whole number like 10. Also integers like -3, that can be written as -3/1. -10, that can be written as -10/1. Now, decimals that are rational numbers are decimals that repeat. For example, no, it's not making me do a point there. 0.12 repeating is a rational number because I can write that as a fraction. We'll talk about that later on. Okay, something like 0.666666 repeating also can be written as a fraction, so therefore it is a rational number. Now, decimals that terminate. A decimal that terminates is a decimal that ends, like 0.125 or 0.5 or 0.83. Those are all decimals that terminate, and when they terminate, I can write them as a fraction. We'll talk about that in a minute. Now, perfect squares are also rational numbers, and perfect squares are the squares that you're familiar with, such as the square root of 25. Okay, the square root of 25 we know is 5, and 5 is a rational number. Something like the square root of 81. The square root of 81 is 9, which is a rational number. So your perfect squares that you're familiar with, are also rational numbers. Now, some irrational numbers. Non-perfect squares, numbers that don't work out smoothly like the perfect squares. So, for example, the square root of 30. Okay, square root of 30 does not work out to be a perfect square. Ends up working out to be a decimal. If you enter that into a calculator, you get a decimal that never ends. So this would be an example of an irrational number. I cannot write a fraction for that. Okay, square root of 110. Again, there aren't two numbers that multiply together to get 110, so it is a non-perfect square. Just some other ones real quick. Square root of 80, square root of 61, and so on. Okay, some other examples of... Okay, so decimals that go on forever and never repeat are also irrational numbers. For example, like 0.5721 ... just keeps on going on, and it never repeats. That is also irrational. Numbers such as 01, 001, 0001. Now that looks like it repeats, but it's just a repeating pattern. I can't put a line over anything in that decimal where it repeats. So I cannot write a fraction, therefore it's irrational. And again, probably one of the most famous irrational symbols, one of the more famous mathematical symbols out there is pi. Pi is irrational because it goes on and on forever without repeating. Okay, take a look at Section 3. Section 3, we're going to take a look at converting some decimals to fraction. Now, in order to convert a decimal to a fraction, you have to be able to read it. So the first one is 0.1. Well, we read that as 1/10. So as soon as you can read it, you can write it as a fraction. So it's a fraction, it's rational. 0.25 is 25 hundredths. So write that as a fraction. And finally, 47 thousandths is 47/1,000. Okay? Now, repeating decimals. One of the things we learned about way back in December is that you could make any repeating decimal as a fraction by simply putting it over the same amount of digits as 9. So, for example, 0.2 repeating is just 2/9. Because it repeats, one number repeats, you only need 1 9. 0.67 repeating. Well, just put, there are two items that repeat, so I need 2 9s. 0.012, well, that's going to be 12 over, how many numbers repeat? Well, 0, 1, and 2, that is 3 numbers. So 12 over 999. Okay, in Section 4, we're going to estimate the decimal value of irrational numbers. So these are non-perfect squares. So can I estimate a decimal value? Sure. So here I have the square root of 90. Well, I know that that's between the perfect squares of 81 and 100. So I know that it's going to be somewhere between 9 and 10. Was it closer to 9 or closer to 10? Well, 90 is like right in the middle of 81 and 100. So I would go with 9.5 for this estimation. Oops. 9.5. About the square root of 27? Well, square root of 27 is going to be between 25 and 36. So that's going to be between 5 and 6. But it's much closer to 25 than it is 36, so my estimation would be something like 5.1 or 5.2. Doing C and D again. So it's going to be between 100 and 121, which is between 10 and 11. 118 is closer to 121, so I would say something like 10.9, 10.8 would be okay there. And finally, the last one is between 121 and 144. So those two perfect squares work out to be 11 and 12. So 132, I would say, is pretty close to midway there. So I would go with 11.5 for that one. Okay, and then the last section on this page, what two whole numbers do the following irrationals fall between? This is something you guys should be familiar with. I know that square root of 6 falls between 7 and 8. What about 108? That falls between 10 and 11. Okay, last page here. Okay, so in this section we're going to write these numbers in numeric order, or we're going to compare using greater than or less than. So in the first one, which number comes first? Well, square root of 8 is between 2 and 3. So I know that's going to be about 2.8-ish. Pi is 3.14. And square root of 20 is about 4.4. So when you rewrite these in order, you can see that square root of 8 comes first, followed by pi, followed by square root of 20. Okay, in part B, which number is greater? Square root of 30 or 6.0987, so on. Well, square root of 30 is between 25 and 36, so it's going to be like 5.5. Well, 5.5 is less than 6.09. Okay, so go ahead and do C and D if you want. Real quick, I'll put the answers down. Okay, so there you can see the answers to part C and D. Okay, and the last thing we want to do is locate the following on a number line. So take a look at the square root of 5. The square root of 5 is going to be a little bit more than 2. So the best guess there would be about D. So I would put D in there. Square root of 9 I know is 3, so that one's kind of easy. It's right there. It's E. Square root of 2 is about 1.4. So the closest letter there would be C. Square root of 16 is 4, which the closest one there would be B. Pi is 3.14, so 3.14 would be about A. And finally, the square root of 45 is 6.7, 6.8, and you can see that's way out there. That is F. Okay, so at this time, now you're done with the video, you can go ahead and work on the homework. Any questions? Feel free to see one of your teachers. Thanks.